problem 55, we're taking a look at different polynomials and trying to just get our basic ideas of what these all are. So first of all, we're going to figure out the degree, list the coefficients, and we're going to list them in order. And then we also want to talk about anything else here really about these polynomials. So for this first one, the degree, remember, is the highest exponent. So I have an exponent of 4, so it's a fourth degree polynomial. Now, if I want to take a look at my coefficients, and a sub o is actually the constant term, I'm actually going to do that one last. So I'm going to start off with the a sub n, and the n goes with the highest exponent as well. So the coefficient for a sub 4 is going to be 6, because as my coefficient, the highest degree that you have here, the coefficient for that is called your leading coefficient. So my leading coefficient is 6. It is a positive 6. That lets me know that I have positive orientation for this problem. So now I'm going to take a look at my next one, my a sub 3. That coefficient is a negative 3. So look, there is a negative 3. My a sub 2, that coefficient is 5. My a sub 1 is 1. Even though there's nothing written there, it is a 1x. We normally don't write 1 times x. That's the same thing as just x, so we don't have to write that 1. So now my last one, my a sub o, or a sub 0 rather, is my constant term, which is 8. That, by the way, as well, would be my y-intercept. All right, taking a look at problem B. It is a third degree polynomial. So it's third. So my a sub 3 is going to be a negative 5. That is my leading coefficient, meaning it now also has negative orientation. My a sub 2 is going to be 10. Now this next one here might trick you a little bit. My a sub 1. There is no x to the first. That would be like that one in the last problem or this one in the next problem. There is no x term, which means that is 0 times x. 0 times x equals 0, and we don't have to write plus 0 in there. So my coefficient for that is 0. And my a sub 0 is going to be, again, 8. For the part C, it is a second degree polynomial. So I now have a sub 2 is going to be a negative 1, negative orientation. This is a parabola that is opening down. My a sub 1 is going to be positive 1. And I do not have a sub 0. There is nothing that's being added at the end. So my a sub 0 is 0. So my y-intercept in this one is 0. Okay, problem D is the only one that's written in a different form. It is written now in factored form. So what I need to do first is multiply these out. I'm going to multiply these first. So I'm going to have x times, and if I make my generic rectangle multiply the other ones out, I'm going to have x squared minus 8x plus 15. And now I'm going to distribute the x, giving me x to the third minus 8x squared plus 15x. So this is a third degree polynomial. My a sub 3 is going to be 1, so it has positive orientation. My a sub 2 is going to be a negative 8. My a sub 1 is going to be 15. And my a sub 0 is 0. I do not have 0 or a constant term. Looking at problem C, it is a first degree polynomial. First, my a sub 1 is 1, and my a sub 0 doesn't exist. It is 0. That, by the way, would be the equation y equals x. It would look like that. And the last one, it is a 0 degree because the only thing I have is the a sub 0, and that is 10.